So today we will discuss about process scheduling. So the aim of process scheduling is to maximize the CPU utilization to achieve the multi-programming. So there may be a CPU burst, IO burst. The process alternate between these two states, between the CPU burst and then IO burst. So whenever CPU burst happens, so it will load the process and then it will add to the store and then it will read from file. And whenever there is an IO burst happens, it will wait for IO request. And after completion of IO burst, so again it will increment the index and then it will write to the file. So sequence of CPU burst, IO burst happens. So there are two types of scheduling. One is preemptive scheduling and non-preemptive scheduling. So CPU is allocated to the process. When high priority process comes, it releases the CPU and serves the high priority process. So in non-preemption, once the CPU is allocated with the particular process, so till the process gets complete, the CPU will not release the process by switching to other. CPU scheduler. The role of the CPU scheduler is to dispatch the process that are waiting in the ready state to running state. There are several states of the process: new state, ready state, running state, waiting state, and terminated state. So when the CPU scheduling happens, so in non-preemption case, it happens whenever the process switches from running state to waiting state, or when it switches from running state to terminated state. And in case of the preemptive case, the process switches from running state to ready state, as well as waiting state to ready state. So whenever a new process is created, it is admitted into the ready queue. And whenever interruption happens, the running process will be put up to the rear end of the queue, ready queue. And from the ready queue, the dispatcher will switches the process to the running state. And once the process gets completed, it goes to the terminated state. Whenever there is a IO related operation happens, so currently running process will be moving to waiting, and finally once the IO completion happens, it moves to the ready state. So the role of the dispatcher is to give control of the CPU to the process. So by switching context, switching to user mode and jumping from one user location program to start that particular program. The delay which happens when switching between one process to another process, we say that as dispatch latency. So what are the scheduling criteria? So we have a different scheduling criteria like CPU utilization, throughput, response time, waiting time, and turnaround time. CPU utilization is how much effectively the process utilizes the CPU, and throughput is and particular unit of time how many jobs are being completed. And response time is whenever a request is submitted, how fast the response comes from the CPU. Waiting time is the amount of waiting time the process waits in the ready queue. So turnaround time is the time of submission between the time of submission through time of completion. So there are various scheduling algorithms. First come first serve scheduling, shortest job first scheduling. So in shortest job first, we have a simultaneous arrival time and then varied arrival times are there. And preemptive shortest job first with varied with different arrival time, we name that as shortest remaining time first. So priority scheduling, it also includes preemptive and then non-preemptive, followed by round robin scheduling. In the next video, we will look at each and every scheduling.